Hello, I'm Fadikemi Zainab Haruna, a final year student of the Federal University of Technology, Mina. I'm a trainee under the HCE Mobility Program, assigned to undergo my training with Smart Water Solutions, Uganda.
I am Barnabas Olawore, a final year student at the Federal University of Technology, Mina, currently undergoing a training under the HCE program attached to Smart Water Solutions, Uganda. The Homegrown Clean Energy Program has its aim of training students in clean energy technologies, thereby providing them with the necessary skills to provide solutions to Africa's problem in energy, in agriculture, in power, and making sure that these solutions are affordable for underserved communities and rural areas in Africa. As part of the prerequisites for completing the HCE program, trainees are tasked with developing a prototype that solves Africa's problem, particularly applicable for underserved communities or rural communities.
Every year, farmers experience a lot of post-harvest losses due to inefficient drying methods like open sun drying, which exposes the crops to contamination, theft, and so on, or completely electric drying methods, which are totally expensive and unsuitable for those with no access to electricity. That is where our solution comes in. EcoDry, a smart hybrid solar dryer that combines both direct solar drying and indirect solar drying with a heater to improve the efficiency of the drying method and reduce drying time. It also includes smart features to reduce human effort. I'll be walking you through the key features of EcoDry, starting off with the solar panel, which receives light from the sun and converts it to electricity. Then on to the charge controller that regulates the charge gotten from the solar panel and charges the battery. The battery powers all the electric components used in EcoDry.
The dryer frame is covered with a UV screen to support the direct solar drying method. It allows sunlight in for heating while blocking harmful UV rays, thereby preserving food quality and preventing nutrient degradation.
Here we have the solar collector. This solar collector warms up the air to aid in direct drying. At the inlet of the solar collector is an inlet fan that blows in hot air, while at the outlet of the drying chamber is an exhaust fan that pulls out humid air. Here we have the drying chamber. This is the tray on which the crops are placed for them to dry. In the drying chamber is a temperature sensor, which ensures the crops are drying at their specified temperature, and a humidity sensor, which ensures that the crops reach the final humidity to stop the drying process. In the drying chamber is also a heater that further warms up air from the solar collector to ensure it reaches the specified temperature for the crops to dry.
In the solar collector is a temperature sensor used to measure the contribution of the solar collector to the drying process.
There is also a solenoid lock for security.
EcoDry is equipped with smart features that reduces human effort. There is a user interface, 2 buttons that allow the user to navigate the user interface, a LED, power LED that shows that the system is powered, and a LED that shows that the heater is on. And then there is a provision for RFID where the user just has to swipe a card and the dryer opens.
EcoDry also includes a web-based dashboard that allows users to remotely monitor the dryer in real time, track the condition of all components, and receive instant notifications once drying is complete.
To use EcoDry, the user has to flip on the power switch to start the whole system. And this is the user interface of the control unit. Currently on this tab, there is environment, which shows the readings from the sensor. With the next button to navigate the different kind of crops that the user wants to dry. Here we have grains, legumes, and different kind of crops. After which, the user selects the crop using the select button, and then select again as guided by the interface, and then the user swipes a card to initiate the drying process. So at the moment, drying has started for the selected crop, which is a legume. Let's say what is currently drying in the chamber. The user uses their RFID tag to open the door to the chamber. In the chamber, here is beans that has been undergoing drying for the past 2 hours. And as you can see, the beans is almost dry, showing the efficiency and the efficacy of this dryer. The drying is completed when the set humidity for the particular crop placed inside the chamber has been reached, and at that moment drying automatically stops by itself without the intervention of the user. A very big thank you to the organizers of this program and the host companies for their efforts and for this opportunity that they have given to us, they have given to me, to undergo this training and to deliver this wonderful project. Thank you very much.
It has been a really valuable experience learning, training, and developing this prototype here in Uganda. And I want to extend my sincere appreciation to the organizers of this mobility program, the HCE Homegrown Clean Energy Solutions Mobility Program, and to our host company, Samrt Water Solutions, to my school, the Federal University of Technology, Minna, and to the European Union for supporting this program. I say a very big thank you. Bye.